So this generative AI did not appear all of a sudden. It is an advancement of whatever has been developed already. So initial phases was basic reporting. If you take this whole data science field or the data analytics field or whatever is data mining, initially it was basic reporting that started around 2000. From 2005, 2004, 5 onwards, we started doing predictive modeling where we use algorithms like regression, logistic regression, decision trees for customer segmentation, etc. And then advanced predictions using random forest, boosting, SVM, these type of algorithms. And then ANN came into the picture. Then came into the deep learning, which is a deep neural network, image classification, text classification. Given an image, we have to find out whether it is a cat versus dog. Given a text, we need to find out whether this is class 1 versus class 0. So that is deep learning, what it was doing. Now we are in Gen AI. It is the generation of the text, generation of the images. Until here, given the cat image, we are able to predict whether it is a cat or a dog. But in generation, what we are doing is, given any of the instruction, we are creating a new image. There would not have been an image like that earlier. Let us suppose if you give an instruction saying that a cat sitting on a boat near the sunset on a beach. If you give an instruction like that, maybe there was never an image of a cat sitting on a boat and there is a sunset behind it and that is on a beach. Maybe there was never such an image, but that image will be generated and it will look quite perfect, that almost it appears that somebody has taken that image. Text also, you can ask, you can give an instruction to generate the text. You can give an instruction to say that I want to understand machine learning, but explain it to a layman, maybe in 4 points. There would not have been any article anywhere written exactly in 4 lines, explain machine learning to layman, but that would be generated. So that is where the whole world is right now. The applications of generative AI are so perfect and the accuracy is so high that every company is right now kind of very much looking into this. Usually I get an idea by look.
Didya ମାନେ student କିନ୍ତୁ ଅଲଗା ଗୋଟେ କାମ କରୁଛନ୍ତି କି ନେଇଦେଲେ
Yes, Sanjarani.
ନା ନା ପ୍ରଭୁ ନା
All right. Where was I? Yeah. So usually earlier I used to give corporate trainings, right? So I am part of a lot of groups and a lot of people have added me into their context list. So whenever they get training requests from these companies, almost in India, nearly like lakhs and lakhs of training programs will happen on all the technologies. But when it is related to data science or anything, I tend to get some mails. Nearly I get around 600 training requests, like calls and the mails, etc., every year. And the number of mails are too many. Based on the training requests, I get an idea on what is the industry trend. From past 6, 7 months, especially from Jan onwards, almost like every company is looking to hire people around generative AI, either hire or train the existing existing resources on generative AI. So this is one of the field. It looks like this is not a trend in fluke. It is looking like it's going to stay for some time for sure, because the applications are quite good. When we are going through this course, you will also realize that this is something that can be actually implemented on some of the problems that we are already solving. They can be solved quite easily by using generative AI. You yourself will realize that whatever work you're doing, maybe it is giving 90% accuracy after putting, let's say, 3 people have built a model for 3 months. It gave 90% accuracy. Now you use one large language model or generative AI related stuff and you use their API. Within 3 minutes, we can get around 95% accuracy. So that is like unreasonably highest accuracy that we will get. So that's what companies are doing. They are not building anything new. They're quickly checking whatever we have it right now. Can we implement generative AI in that and can we improve the current existing process? I'm going to show you some of the applications that are already, we are already doing it with some of the predictive modeling or machine learning or reporting techniques, how generative AI can replace them. There are two sides to generative AI. One is the language data or the text data side. The other one is the image data side. On the text data side, you have large language models, you have chatbots. Chatbots are not necessarily you are chatting with an agent. A chatbot is something like you can upload a document, you can chat with your document. You can upload a data set, you can chat with your data set. That's what chatbot. Content creation, code generation, especially the code assistance, language translation always been there, email communication assistance, etc. So this is the language side of it. This is where there's a lot of buzz, and already some of the applications have been built and they are working. And this is like it has taken off like anything. The last 6 months itself, everything, like almost all the companies have actually started implementing this. In every company there must be a team that is talking about generative AI for sure. The second side is image data. It looks cool, but I'm not sure in enterprise level. People have started using it. I am not really sure. Face detection, object classification, self-driving cars, image generation. I'm not sure the kind of like if you talk about the Indian context where we outsource all our services, maybe in the Indian context or in the data science context, maybe this side we haven't yet explored, but there will be a lot of buzz, there will be a lot of talk because it sounds cool. It sounds really good when somebody is talking about some of the cool videos that have been generated by Sora or something. But from the application point of view, this is the side that is going to be very useful for us. From the job upgradation point of view, also, if you say that I already work on some of the models using generative AI, we have transformed them into the next level. If you portray your CV like that, then there's a very high chance that you may crack a job that is paying almost double to triple to whatever you have right now, because the resources will not be that many currently in the market. So in this whole workshop, what we are going to cover is almost I have divided it into 6 modules to make it easy for anybody to understand. Some of you already have machine learning background. Some of you may not have machine learning background. So I'm assuming that nobody has machine learning background. Maybe some of you have learned machine learning earlier, but maybe you did not get a chance to work on it. You may have lost touch. So keeping that in mind, initially, I will recap some of the ML key concepts. If everybody says that it's okay, then we'll recap. Otherwise, we'll skip those sessions. If it is important, then we'll keep it. And then we will get into some of the important concepts within deep learning, ANN. So module 1 is introduction to generative AI, introduction to large language models, prompt engineering part, and then recap of machine learning concepts. Module 2 is there are some fundamental concepts that generative AI is actually built upon. There are something called word embeddings and artificial neural networks. That is a core concept that we must understand. Then comes all the actual generative AI stuff where we will be talking about Hugging Face large language models. There is a framework called LangChain. A framework is a software program or software tool that makes our life easy for programming. When we are interacting with large language models, we will be using a LangChain framework. Within that, there is a concept of chains, and then there's a concept of input, giving various inputs like PDF, inputs like Wikipedia data, inputs like text data, and then output, extracting the output in a certain predetermined format. And there is a very important concept called retrieval augmented generation. So usually large language models are built on the whole world of data. Now, if I have some private documents, which is what we will see in our actual industry, in the industry, we have private documents. How do you apply a large language model on your private documents? How do you retrieve the information? Retrieval augmentation, augmenting your private documents to a large language model. I'm going to tell you what exactly is large language model also. And then within that, there is a LangChain, memory, chatbots. And then nowadays, everybody is creating something called agents. So basically, agent is almost like a proper robot, which is doing all your job on its own. If you just submit one request, automatically the code will be generated. Agent will check whether the code is right or wrong. If the code is wrong, then the agent will go back and rewrite another code. It will check whether it is right or wrong. If it is right, then it will give you the final result. So agent is almost like a proper artificial intelligence, how to build them. That also we are going to see. And module 6 is kind of optional. The theory behind, like here all we are going to see applications. Now the theory, exactly what are the derivations of some of the deep learning algorithms that we discuss. what is the theory of transformers. So at the end, we will see the theory part as well. So this is what we are going to discuss in the upcoming sessions. Are there any questions, anybody? Quick questions?
No, sir.
No.
Good to go.
So what is the required background? I would say the required background is if you have graduate level, any graduate is good enough to learn this. Only thing is for some of you, you may grasp the concepts quite quickly. Maybe for some of you, if you're not grasping the concept within 2 hours, spend 3 hours, otherwise 4 hours, 5 hours, but eventually you will be able to grasp it. It's not like rocket science will not be able to understand. It's quite easy once we get the hang of it. So initially basics, if you try to focus clearly, automatically you'll be very comfortable with it. Mm. All right. Let's go to some of the basics of prompt engineering. Already, some of you might have attended my previous prompt engineering session. This will be a recap, maybe a little bits of pieces I have added. Otherwise, it remains the same almost. So let's get a hang of what exactly are large language models. Why are they called large language models? And there are multiple ways of interacting with large language models. We are going to now see one or two ways of interacting with large language models. Any quick questions before I proceed? Anybody? Okay. So if I ask you, have we really used these large language model earlier, or have we used any language models in general prior to, like, right now there is a lot of talk about large language models, generative AI. Have we ever used any of these language models earlier? Yes, we have already used them. But only thing is that we did not pay much attention to them. Maybe in some of the cases, a few years back, you may have interacted with a chatbot. Those chatbots are known as rule-based chatbots. That means depending on whatever you are giving as input, it will extract some information from the predefined rules, from the predefined documents. It will try to give you the output. For example, in Amazon, if you type a review or if somebody types a review, automatically Amazon extracts whether it is positive or negative and find out what are the points that are positive, find out what are the points that are negative. Or sometimes in LinkedIn, when you write a post, automatically some hashtags are generated, some of the hashtags. That is also an example of language model. When you type something in your phone and then automatically the rest of the words or at least the next word will be predicted. That is also a language model. These are all like relatively small or regular language models. What do you mean by relatively small models? Like these are the ones like the taking the review as input, predicting the output, whatever we see on the Amazon, the sentiment analysis model, predicting the next word while we are typing in your phone. That is also another type of language model. Finding the keywords. These are relatively small language models, which we already used. But what are large language models? At the core of it, what do these large language models do? At the core of it, these large language models predict, in simple words, they predict the next item in the sequence. That's it. These large language models will take your input. Let's say if you give the input, oh, what a lovely, it will take this as input. It will predict the next word. Only one. It is not even called word. It is called as token. Next token will be predicted. Oh, what a lovely car. And by taking this as input, oh, what a lovely car, the next one word will be predicted. I. What a lovely car I would. What a lovely car I would like. Then all this will be taken as input. What a lovely car I would like to. What a lovely car I would like to buy. What a lovely car I would like to buy one. Like that, every time one token will be predicted. Have you observed it when you are using Chat GPT? The output will be generated, like if you observe it quite carefully, when you try to slow it down, how it is generating one by one word it is giving. Have you observed it? And if you
Yes.
keep
Yes.
on
Yes, Venkat sir.
Yes, sir.
if you keep on doing it, if you run it for too much, then we may lose the original context. That is why I think ChatGPT max to max 2000 tokens or 1000 tokens, it will stop. That means max to max it will generate for 1000 tokens. Beyond that, it will say that it is beyond that. Or maybe if you are using the paid version, hardly it will go for 4000 tokens and it will stop there. So large language models, simply what they do is they predict what is the next item in the sequence, that to one item in the sequence, that's it. But why are they called large language models? They are called as large language models, large because of mainly three reasons. I mean, this is my understanding of it. It's not like defined everywhere that this is called as large language model. This is the definition. But the main reason why people call these as large language models, because of three reasons. The first reason is large amount of data is used. There are large number of parameters that are used. There are large scale computations that are used. Usually when you are building a sentiment analysis model, given the review, you want to predict whether it is positive or negative sentiment. Usually what you tend to do is you may use 5000 positive reviews, 5000 negative reviews, or 15,000 positive, 15,000 negative, or maybe 50,000 positive reviews, 50,000 negative reviews, and then build a model. That is the amount of data that we tend to generally use. Or if the data is too large, maybe 5 million positive reviews, 5 million negative reviews that we take to build this model. But the model that we are talking about, the large language model, the input data is literally the whole internet of data. These large language models have been trained on enormous amount of data. Almost all the books and literature databases are used for training. Almost all the scientific articles, almost all the journals, every journal is used for training. All the websites, billions and billions of websites, all these large language models, for building them, they have been scrapped, and then after scraping those websites, the information has been given to these large language models. All the blog posts, all the social media forum discussions, all the news articles, all the dictionaries, even the dictionaries, open source data sets and repositories, everything that is available in internet. In fact, some people say that these large language models have been trained on the whole internet of data. Whatever is available, the whole internet of data has been used for building the large language models. So it's a huge amount of data. The reason why we call these language models as large language model is large amount of data. The second reason is large number of parameters. The parameters that are used for building these models are too many. What do you mean by a parameter? Let us suppose if you are building a logistic regression model. If you are, let's say, forget about logistic regression, if you are building a model that will predict the credit score, CIBIL score, or any of the credit score, before giving a loan, a bank has to decide whether the customer is a good customer or a bad customer. Before building a model, we calculate this credit score. To calculate this credit score, we use payment history, debt to income ratio, card utilization, length of credit history, types of credit, etc., etc. Various variables we will use. Let's say around max to max 100 or maybe 50 to 100 features we use. Let's say I'm using, for a particular problem statement, I'm using around 75 features, 75 variables, 75 attributes for predicting the credit score. These 75 attributes will have 75 weights. Each attribute will not be given the same weight. It will have some weight 1, it will have some weight 2, weight 3, weight 4, weight 5. This weight is known as, whatever is the weightage that we see, that weightage is known as parameter. That means hardly how many weights will be there, how many weight parameters will be there in a credit score model. Hardly there will be 50 to 100 weight parameters will be there. That is a typical credit risk model that we build, whether you go to Citibank, whether you go to HSBC, whether you go to Bank of America, Credit Suisse, wherever you go, roughly 50 to 100 weight parameters will be used in building a credit risk model. Do you agree with me? Anybody working in credit risk already? Usually, how many variables will be used in the final model? Maybe even less than this. Yep. So, if you ask me how complex is a credit risk model, I would say it has 100 parameters in it. That is a complexity. But if you talk about a large language model, the number of parameters, some of the large language models are GPT, GPT-2, GPT-3, the chat GPT behind the scenes, GPT, this is the model. GPT got released in 2018. It has 110 million parameters. So I'm talking about 100 parameters here in a credit risk model. Credit risk model. What does a credit risk model do? It will predict whether a customer is going to be defaulter or non-defaulter. Let's say it has 100 parameters. GPT, which got released in 2018, it has 110 million parameters. And that was one of the poorest, one of the low performing model. GPT-2 got released in 2019. It has 1.5 billion parameters. 1,500,000,000 parameters. Now this people did not like it. After that, GPT-3 got released. After that, that became Chat GPT, and people got really crazy about it. Like it gave huge accuracy. It has 175 billion weights or the parameters. 175 billion parameters. Right now, I think we are beyond this. GPT-3X Turbo is also there. 1.575 trillion parameters. Right now, are we using GPT-3? No, GPT-4, GPT-4XO. Have you seen it? When you go to Chat GPT, the version that we are using is, in fact, the slide itself, the slide that I'm showing right now, it's a kind of outdated one. Because recently, I think last month, GPT-4XO or 4O, GPT 3.5. So this one is GPT 3.1, I guess. GPT 3.5, GPT 4o. This is the most advanced model. It might be having trillions and trillions of parameters for sure. So are you getting a hang of how large these models are? Compared to a credit risk model, which has 100 parameters, these models are quite huge, quite huge. Obviously, if you are handling that much of data to capture all those patterns in the data, you got to have these models that are quite huge. That is the second reason why these language models are called as large language models. The third reason is large scale computations. It is very obvious that if you are using this much amount of data, and if you're also using these many parameters, you need very high-end computations. So it's not possible to build these type of models easily on a commodity hardware like whatever laptops that you and I are using. We need almost supercomputers. A lot of GPUs are required, graphics cards, so that we can parallelly process several computations. Apparently, just for GPU, just for the graphics cards, this OpenAI company, they have spent around $100 million, which is like loosely 820 crores. Almost we require 1,000 crores to build one large language model. So there is no way a company can actually invest in building a large language model unless until they see a huge value in it. It's better to take someone else's model and then use their, whatever API, use their model by paying them. We will use it, their services, because it takes around 1,000 crores. That is just for the hardware. I'm talking about just the GPUs. But you have to employ people, you have to make sure that this project is completed on time, etc., etc., it's performing, etc. So there are large amount of data, large number of parameters, large scale computations. Because of that, these are known as large language models, and the results are amazing, quite amazing. The large language models have surprised almost everybody. They have generated the code. I have seen the phases where we used to feel very happy if you say generate code, if you just give something related to code. Let us suppose if I go back to 2015, 2016, using deep learning, some people have demonstrated I can use deep learning to generate code like content. That means exact code they cannot generate, but if you say generate code for Python importing, then the model will give as output import import panda and then PD. This is wrong. It will not work. Import panda PD. That's it. But people used to feel, in fact, I was also very happy. I was so surprised. How come a language model can understand our whatever requirement and then it gave almost something related to code. Nothing is related to our general language. Like people were very happy with this result itself. Maybe another request was write a tweet, something like write a tweet as if it was told by Donald Trump. Then the result was something like, we will not let them enter. Let's build a wall. People were like damn happy looking at this. If you go back to 2016, during that time, around 6, 7 years back, getting a result which is related to whatever is the request that we have asked, generating a result was a big success back then. Compared to that phase, within 5, 6 years, we are at a phase where everything like code is generated, hundreds of lines of code is generated, and that code is perfectly working. Generating the creative content, forget about writing a tweet. We can actually write a whole poem itself, and it is having perfect rhyme. Sophisticated Q&A also they are doing, like whatever LLMs, large language models doing right now. If you ask me, if I go back 4 years back, if you would have told that there would be a model that will generate code and you can execute it, or let's say 6 years back, there will be a model that will generate a poem and that poem will be totally meaningful and it will give you that poem to your context, then we would not have believed it. Yeah, please go ahead with the question.
So, good morning, Raj.
Yeah, yeah,
So, I have one query.
yeah.
Like you said, these models are trained outside, and no company has, no company would invest huge amount of uh, their capability into this. So, we are leveraging the models which are already trained.
Hmm.
But doesn't it come with a security lapse, like, for a bank, PII, PIA data or the data is so crucial and so important, and we are giving access to outside the model to have access on our data. Don't you think it will create a security breaches in the coming time, and a single model will have access to, like, Citibank is using the same model, HSBC is using, CBA is using. So this model will have all the information from all the uh, financial resources, and this might create a security concern in future.
It's a very good question. In fact, that's the first thing, not only banks, almost every company thinks of it, that this large language model has been trained on an internet of data. And if I'm using my data to get the result, is it a security concern or not? So there are two ways to look at it. At the end of the day, what is a large language model? It is not a software program. A large language model is a equation. In what is a equation or what is a model? Let us suppose in HSBC, I have built a model, a credit risk model. At the end of it, they will give me an equation, isn't it? Y equal to e power beta naught plus beta 1 x1 plus beta 2 x2 divided by 1 plus e power beta naught plus beta 1 x1 plus beta 2 x2. That means if you supply this one and this one, x1 and x2, let's say x1 is income, x2 is number of loans. Based on income and number of loans, I can predict whether a customer will be defaulter or non-defaulter. This equation is the model. Okay. But this large language model will be a sophisticated equation, obviously, isn't it? Quite a sophisticated equation. Here you have 1, 2, 3 weights. Here there are billions and billions of weights. Okay. But at the end of the day, this is a sophisticated equation only. And these are the variable names. Here the words or the word tokens will be the input. Let us suppose you are using, let's say this has been built in HSBC by Venkat. Okay. Now you are in Citibank. Raj is in Citibank and I have passed this model to you. What you have done is from Citibank, you have supplied your income for your customers, your number of loans, and you got the predicted values as defaulter, non-defaulter. Now sitting at HSBC, can Venkat get to know your personal data? Think about it. You have used the model, but this model is not in an online model where it is sending the data to somebody else. Are you getting what I'm trying to say? You're
Yes,
using
sir.
the model to make a prediction. Okay. You're not retraining the model by supplying your data. Are you getting it? If you are retraining the model, let us suppose in HSBC, it happened that income and number of loans are the most important factors. But in Citibank, it is income, number of loans, and number of late payments. If you retrain the model and then send it back to HSBC, then HSBC will get to know that number of late payments also very huge impacting factor in Citibank. But HSBC will never get to know if you're just using the model for prediction. Are you getting what I'm trying to say?
Yes, sir.
Yeah. So that is point one. So when I say large language model, it is not like an online service where we send the data and somebody will analyze that data and give us the output. A large language model is a huge, complex, deep learning model equation. Okay. That is one. And number two is, even we are not even comfortable. Let's say sometimes these large language models, some of the large language models, they don't allow us to download. So right now I gave you an equation. I gave you an option of downloading this model. That means I have sent you this model physically in an email so that you can use it in your system. So that answers, like if you're downloading, using it locally, no question about sharing the data. It is totally like the way earlier you used to build the model, like the way you have built a logistic regression model inside your company, used it. Similarly, you can download my model, use it. Okay. You can save it as another model and use it. The second one is, yes, some of the large language models, they don't give you their model because it is proprietary, especially OpenAI. For OpenAI, you have to send your data and then they will analyze and give you. In that case, there is an option. There's an option called RAG. That means you have an option to augment your documents. That means you take the output. What you need to do is, in RAG, we convert them, we encrypt them into some vectors. After encrypting them into vectors, so earlier you have the data, but that data is encrypted into almost vectors, and those vectors will be sent. These vectors will not be understood by anybody. We get the output and then we synthesize the output. So a simple answer, or the most safest answer, would be take a large language model, keep it internally to our own system. So what companies are doing is, there are so many large language model providers right now. There are so many companies that are providing large language models. Quickly, these big companies are buying them. Let us suppose OpenAI, it is very difficult to buy them. But if you have security concerns, there are some other companies. There is a company called Cohere. So Oracle has bought Cohere. Okay. Maybe Citibank, either they will develop it or they may buy a small company that has developed a large language model which is working effectively. Are you getting what I'm trying to say? Or we may have tie-ups with these large language model providers, and we may have these security protocols and so on kept there. Okay. Because when we were using SaaS, we never faced that security issue because we have a understanding that SaaS will not take our data, send it to anybody. A similar setup will be made, similar protocol will be made.
Venkat sir, one quick question.
Yeah.
Uh, so far, I think this LLM models has been more successful in content generation,
Hmm.
but in the predictive world,
Hmm.
maybe forecasting, retail side, it has not been proved as a very strong outcome. Is it
Not yet.
because of you are saying maybe the infrastructure issue or it is the exploration issue? Where is the issue is?
These large language models, the middle L is the issue. These are all language based models.
Mhm.
So what happens while building these models, anything that you give as input, that will be converted into a vector format. Let's say
Okay.
if I give all this as input, this text will not be taken as text as input. Everything, let's say word will be converted as vector, or the whole sentence will be transformed into a vector. Even if you give numerical data, let's say if you have a sequence of sales, okay, 30 days sales I have. Even if you are giving that numerical data as input, that will be converted into a vector. So even your numerical data, let's say if you write 1 plus 1, it is 2, very easy for a calculator. But for a language model, this is like 1 plus 1. And based on its knowledge, it will try to predict that is 2. And then it
Got
will
it.
be giving it to you. Basically, at the core of it, these are all language models. So they are converting our numerical data into language data, and then like vectors, and then based on that getting the output and then giving us. But by considering this, the kind of job they are doing on numerical data converted to vectors and giving us the output, they are doing a brilliant job. But in future, what is happening, or in future or currently what is happening is people are creating some tools and agents. So you can tell a language model that this is numerical data. I'm expecting mathematical computations on it. Use calculator as a tool. So don't use your
Yeah.
original methodology of calculations. Use calculator tool. So we can mention certain tools. Okay. Now I'm
Yeah.
asking you to give the Python code. Don't consider it as a similar text. Use Python REPL tool. Okay. Like that, the tools and agents are the ones that will make these calculations better. But it is true that right now their accuracy is not as much as they are doing in actual text data.
Got it, sir. Thank you.
Mm.
Thank you.
Venkat sir, I have one question. This is Rishi Patel speaking.
Yeah, please go ahead.
So Venkat sir, I would like to visualize when we say billions of parameter LLM trained on.
Mm, mm,
Billions of parameter mean what? Weightage is a technical thing. I got it,
mm,
but similar to weightage, right? But
mm.
if I would like to visualize in my head, is it the features? It's like columns, number of columns they have trained on, billions columns they have trained on.
So basically this, we will get an idea on the parameters when we reach artificial neural network. But quickly, I'll give you a sneak peek into that. Okay. Usually what
Okay.
happens is the simple models that we say, let's say if you're talking about linear or logistic regression model, those who
Mm-hmm.
understand, you get it here. Otherwise, anyway, we will go in depth into it later. So you have X versus Y. So you have X. So let us suppose usually these all the large language models or any of the advanced image processing models, at the end of the day, all of them are artificial neural network models only. Everything is built on top of artificial neural network only. So X is my input. In my input, I am using, let us suppose, 5 features or 5 variables. What are the 5 variables that I'm using? I'm using number of loans, number of late payments, income, expenses, and then number of dependents. 5 features I'm using to predict whether a customer will go defaulter or non-defaulter. So you denote your features as nodes, you denote their weightages as these edges. Now, if you are talking about this credit risk model, which has 5 features, the number of parameters in this are 5. Okay. But what happens when it comes to large language models, or if you're talking about a sentiment analysis model, the X is not directly connected to Y. Input is not directly connected to output. Between input and output, now this is called output layer. There is something called hidden layer that is added, and there's a reason for it, which we will discuss later. Now here, the parameters will be everything that is in the input will be connected to the node in the hidden layer. So all these will become weights. So even though you have only 5 input features, but the number of weights will be these 5 plus 5 plus 5 plus 5. 5 into 4, 20, and then 4 into 3, 12. Overall 32 weights will be there. So 32 parameters. So it's a model with 5 features, but 32 parameters. Are you getting? So the parameters, so at
Got
the
it.
end of the
Got
day, these large language models are very highly advanced, deep neural network models. And we will have a very much in-depth discussion on it probably next to next week. There we will,
it.
once again, in fact, there will be one exercise where we will calculate for a given network how many parameters are there. We will calculate that manually. Okay. So those
Okay.
parameters are those weights. Okay. Which will
Okay.
tell you the complexity of the model.
Mm.
Yeah. Carry on with any connected questions. Let's go into a little bit more details. some of the famous LLMs as of now, almost like n number of large language models are there. N number. There are so many models are there. Google has given Bard, Gemini. Anthropic by Claude is one of the best one that I have seen. A lot of people don't pay attention to this, but this Claude Anthropic, there is one LLM which I am frequently using it nowadays, giving quite great results and quite fast compared to ChatGPT. OpenAI, ChatGPT, and then Palm 2, you have Google's one again, Copilot by Microsoft. Like that, every company, every big company, either they have a large language model or they have purchased, like something like Cohere, they have purchased a large language model from some other company. These large language models were there. It's not that they weren't there, but ever since ChatGPT came into the picture towards the end of 2022, during this time, whenever this ChatGPT came into the picture, general public started using it, and the accuracy was quite high. And then people started paying attention to these large language models. Suddenly, Google also realized that the number of searches have reduced. People have started using ChatGPT. In a haste, quickly they have released Bard, but it was half cooked, and then they have made it to Gemini, etc., etc. Okay, if you ask me, until here there was not buzz. Like the real buzz started after this, and it is going like this. So if you ask me, the whole development, the development was like this, or the interest was like this until this point. But from here onwards, especially I'm talking from the enterprise point of view, the talks were going like this, and it is here to stay. Like usually what we think is, we always talk about numerical data analysis only, because the tools, the programming languages, everything that we could do was related to numerical data analysis only until now. That is why we did not really think beyond this. But now there are new avenues that will come up. Earlier we thought that there are some problems that we cannot solve, just simply leave them. But now we will bring in LLM into the picture. We can solve so many problems that were otherwise simply left because there is no way to get or extract any information out of that. Okay. So this is the history timeline of large language models. You have ChatGPT, GPT-4, I think GPT 4.0 is coming up. So the buzz is largely around these 4 large language models right now. OpenAI, Copilot, Gemini, and this is a good one. Like a lot of people do not know about it, but if you start using CLAUDE, Claude, you will actually like it. This is as good as ChatGPT, and it is working very effectively. Let us do an example. There are 2 ways to use your large language models. Either you use their interface on ChatGPT. Let's say if you want to access ChatGPT, either you can install an app or you can use their website. You can go to their website and ask a question. Go to their website, ask a question. That is one way. We can ask a question there, whatever the question that we want to ask. We can go to, let's say if I go to Claude, this is ChatGPT. If I go to Claude, let's say if I want to ask a question, what is the best way to learn anything new quickly? Start with basics, use active learning methods like practicing, find a way to make it interesting, and then immerse yourself fully, listen to audios, tutorials. Basically, you have to totally get into it day in, day out, day in, day out. If you do that, automatically you will learn it, because most of the times we will not be able to learn because a lot of terms are very new, or a lot of terms, the terminology itself kills our interest. If you are totally immersing yourself into that, you're watching the videos related to that, you're watching the shorts, YouTube shorts related to that, you're listening, or unknowingly, subconsciously, automatically, you will get an idea on the terminology. Then the whole learning becomes very, very fast. Okay. Learn fundamental concepts, make sure that the fundamentals, we are not taking them for granted, and then experiment, make mistakes, etc. So basically, this is one way you can interact with large language models, but this is not the way companies are expecting you to interact. This is for the personal interaction. If you want to get any output out of the large language models, you do it this way. But the actual way that we will be interacting is using an API. So let us do a quick exercise of using a large language model API. Let's open a code file, open a Google Colab, all of you. Meanwhile, if you have any questions, please let me know, anybody. I will pass on this PPT video along with the code file. In this particular session, there is not much of code, whatever small piece of code that we write, that also, all of that will be uploaded onto LMS. And I think you can get in touch with Sajid. He will give you access to LMS where you can download all these code files. Okay.